the participants and our today's faculty. Ma'am he is Vice President in Mega Ferry, and today lecture is Subsurface Drainage and Groundwater Recharge. So all of you know that we are conducting this online mode of the training program on surface and subsurface drainage management. This training program has already been started yesterday, that is on 2nd of January. Yesterday we have already covered the requirement of and overview of the drainage. And I will again request to the participant that please make it an interactive session. Please ask your questions, or if you have any doubts, please clear your doubt during this session. At the end of the presentation, there will also be a question answer session. However, during the presentation also, if the faculty permits, participant can also ask their questions. Today also there will be a 10 to 15 minutes time break at around 11 to 11:15. So now I will not take much more time. I request Mrs. Minimol Korulla Mam to start his presentation and her experience with the participants. Thank you. Minimol Mam, now you can start now, madam.
Okay. Can you hear me?
Yes, ma'am.
Okay. And can you see the slides?
Yes, ma'am.
Okay. Yeah. So the first slide, subsurface drainage and groundwater recharge. Is it visible?
Yes, ma'am.
Okay. Thank you. And why I am asking is because I feel that there is a small connection issue. So can you see the contents? That is the second slide. Is it visible? Hello.
Yes, ma'am.
Can you see the contents?
Yes, ma'am.
The second slide.
Yeah, visible,
Okay,
ma'am.
fine. Okay, and the third slide, part one,
yes,
that also is
ma'am.
visible.
Also
Okay,
visible.
fine. Yeah, great. So subsurface drainage and groundwater recharge. This is the syllabus which is given by IIH, prescribed by IIH. So in this we will see the sources of moisture in lower layers of pavement, because when the moisture is entering the pavement layers, that is going to degrade the quality of the pavement layers, and ultimately it will be degrading the quality of the performance of the road. And from where the moisture is entering the pavement, if we are controlling the moisture entry to the pavement layers, definitely that is the most effective method. So the water can penetrate from the layers below the pavement layers, or it can infiltrate from the surface water too. So we may have to really think of both the sources, then only we will be able to control the sources of moisture in lower layers of pavement. And treatment of subsurface moisture, different aspects again we need to consider, and different types of tools and different types of materials, the conventional as well as the new type of materials, which may be helping us to reduce the consumption of the natural resources. So what are the different types of the materials which are prescribed by the IRC documents as well as the Bureau of Indian Standards? We will see that also. Okay. So the most important pavement layer when we are thinking about the drainage, it is GSB, right? So the GSB drainage layer. In the GSB drainage layer, we used to consider the GSB itself as two layers, and we will definitely talk about it. Another subject is geosynthetic composite. Geosynthetic composite is a new technology material which will be helping to replace the aggregate layers by the composite material which is made of a geonet sandwiched between two geotextiles. Then we will see fin drains defined by IRC 34. Another topic, subsurface drain for intercepting seepage water in hilly terrain. When it is going to the hill roads, the drainage plays a very important role. So we will see that. Then capillary cutoff, aggregate drain. So 11 o'clock we will take a break, and before that we try to cover all the introductory sessions, and then we will go to the groundwater recharge. In the groundwater recharge, we will see check dams, percolation tanks, and contour trenching. So we are going to part 1. So significance of drainage. Before I am going to this one, I want all of you to write or think in your head, what is the significance of drainage for you as a civil engineer or as a highway engineer? Can you think of one points? Okay, so I will give 2 minutes just to think about what is the significance of drainage for you when you are going to attend a problem or a project. Yeah, then only I am going to the next slide. So the silent 2 minutes. I suppose by this time you must have written the at least one point. Okay, written in your mind or written in a paper in front of you. Now I will request another 3 points also. Can you take why the drainage is so important? First point, I am sure everyone will get. But what is the second, third, and fourth point? Whether it is regular roads, whether it is hill roads, whether it is coastal road. Again, 1 more minute for that. Okay. So I am sure that you must have thought or you must have written something. Okay. So as a pavement engineer or a highway engineer, we all know that the drainage, if not proper, it can lead the undesired water, which will cause damage in pavements. The poor water pressure built up in subgrade may lead to pavement permanent failure. Loss of subgrade support. So the subgrade will become ineffective. Even if we improve it, even if whatever we do that, but if the drainage is not controlled, the subgrade will means and say become ineffective. Reduction of granular layer stiffness. Granular layer, it is now a costly affair to provide more thickness, and that thickness will become ineffective when water is going through that, because its friction will reduce, its shear strength will reduce, its stiffness will get reduced. So in effect, the thickness, we can consider it is getting reduced. Yeah, I want you all to read this and see the image here. Again, I am giving 2 minutes. Please give the image. Hope you have all seen that. So what is the image? The image is showing the water bodies or the water, how it starts its movement journey, and how it may be moving to a water body like a river or lake in a hill road. Okay. So this we are taking it as a typical condition which will be giving the cover of the different types of situation.
Ma'am, not audible.
You. We will meet again at 11:15.
Okay, ma'am.
All right. Okay.
Okay, ma'am.
So we have to start with the geosynthetics. So I'm sure that most of you must have heard about geosynthetics, but anyone who doesn't have that much understanding about the geosynthetics, let me give a one line definition. So I told about the aggregate drains can be replaced by geosynthetic drains, and I again told that it will be most appropriate product for that is a geocomposite, which is a combination of geonet, which is sandwiched between two geotextile. Okay, so let us see one by one the different types of the family members of geosynthetic family. The first is geotextile. Geotextile is a fabric which can be non-woven or woven. Okay, woven geotextile is like our regular cloth, which is having warp direction and weft direction. Okay, but normally these woven geotextiles are being used for either as a reinforcement, which gives strength, or as a confinement, which is in the case of the geotextile tubes or geotextile bags which are being used in coastal erosion or coastal applications for dredging applications or waste disposal. Okay, but we are more thinking about non-woven geotextile. This non-woven geotextile, you will not be seeing any warp direction or weft direction. It will be the fibers will be placed randomly and it will be bonded together by thermal means. Then we will call it as a thermally bonded geotextile. When we are using mechanical means, then we will call it as a needle punched geotextile. Okay, so this is the major geotextile. Geogrid is again a reinforcing material. It is not relevant. This is a very important material, but it is not relevant for our today's session. Then again, geocell is can act as a reinforcing element, as a erosion control element. Okay, but again, not so significant for drainage, so I'm not taking it. Geomembrane is there, which is having some significance to the drainage, especially in applications like landfills, but it is not having that much importance for the the payment drainage. Okay. The next is GeoNet. In the GeoNet, yes, we are having importance because as I told that the drainage geocomposite is, it is something which is sandwiched between two geotextile. That is the drainage geocomposite. So what is getting sandwiched? GeoNet. And this GeoNet is, in fact, it is something which is creating a space, and it should have good durability properties, and it should not subjected to deformation when pressure is applied on it. Okay, so you may ask that where the pressure will come. Okay, we can take situation by situation and understand that how the pressure will come on different drainage elements. Okay, so just understand that the drainage geocomposite is a combination of geonet and geotextile in most of the cases, and in some cases it is the geonet sandwiched between one side geotextile and the other side geomembrane. Okay, where we want like capillary cutoff. In some cases we want one side impermeability, so that case we can put a geomembrane. But in most of the highway situations, the drainage geocomposite, what we are using will be a geonet sandwiched between two geotextiles. In this case, some people may ask that can we use a geotextile, a thick geotextile itself has a drainage path? Answer is yes. If the draining water is having small quantity, then we can go for just a thick geotextile. We don't have to go for a three-dimensional product like two geotextile and in between a geonet. And finally, geomat. Geomat is, again, we may have to talk a bit, because in hill rods drainage, we have to combine the erosion control and drainage. And in that, it's a very good material which can go in combination with the different type of drainage systems. Okay. So I'm skipping a little bit about geosynthetics. Let us go to specifically how the drainage geocomposite can be applied for highway payments. Okay. So what are we seeing here? We are seeing, in fact, the uh, the the flexible payment section where BC, DBM, base, sub base, subgrade, all are there. Okay. So if we don't want to reduce the material, okay, or reduce the thickness of different layers, we just want to increase the durability, and by introducing the geosynthetics. Okay, so if somebody is telling me that a road is there, and there a lot of subsurface flows and a lot of heavy loads are going, so the road is getting deteriorated every year, a lot of maintenance is required, and you don't have to think about reducing the thickness cannot be reduced. You include something when you are redoing the things, you include some geosynthetics to increase the strength. I will be very happy. Okay, I know that I can reduce the thickness, I can really bring down the material cost. But the the client is telling that no, you don't have to try for the material is already there, it is already procured, and it's means, and see the thickness we don't want to reduce it but increase the durability. What I will do, I will go in a little luxurious way. Okay, I will go and introducing a base reinforcement and sub base reinforcement, which you are seeing the dotted green line. Okay, and then a asphaltic reinforcement. The asphaltic reinforcement, there I can go for paving fabric, I can go for a instead of a geosynthetic asphaltic reinforcement, I can go for even steel asphaltic reinforcement. So I can put all this green material you are seeing, it is a reinforcement. Okay, then with the asphaltic layer, the reinforcement, I can add a fabric also. Okay, so drainage layer, where I will use the drainage layer. I will use the drainage layer between the subbase and subgrade, because I'm not reducing the thickness. Okay, so in this case, I may be able to increase my the durability. If the design life which is being taken is say 20 years for the payment, with the every 4 year there is a maintenance provision is there. I can simply go to, instead of that 20 years, I can go, means say almost 35 to 38 years without any maintenance. Okay, and it will be much more than that, but definitely a guaranteed. Before doing any analysis or any type of review, I can just tell that yes, it can go to some 35-40 years without any maintenance. So that definitely will be able to tell by somebody who has worked in this field a number of times and seen that the how the rods are getting deteriorated and how the geosynthetics are really performed well for years. All right, so the in nowadays the geosynthetic materials in our country, more than increasing this durability concept, that people will take, but the more adaptability is wherever we can reduce the thickness. Okay, so that durability concept also will come, because IRC 59 got published in 2019, and the popularity is increasing. More and more rods are getting constructed with the drainage geocomposite, horizontal drains, vertical drains, everything is getting constructed. Okay, by 2029 we will see that 10 years a lot of performance, and then we may be in Senesi really accepting that yes, there is a sharp durability increase. But at present, if we have to go for this alternate material, the main attraction for the contractor as well as even for the end client, it's how much we can reduce the material consumption and how much we can really means Senesi contribute towards the sustainability, and how much means say the cost effectiveness can be achieved. So in that case, the how the drainage composite will be applied. So the drainage composite, again, the application, instead of the junction between the subbase and subgrade, we may use it as a part of the subbase. Okay, we may use it as a part of the subbase, and we can drastically reduce the subbase thickness, and in some cases the entire subbase can be replaced by the drainage geocomposite. So the subbase thickness, say it is 200 mm, and the overall pavement thickness is 630 mm, and if I'm replacing it with a drainage geocomposite, and drainage geocomposite, it means it is in millimeters or microns. Okay, so the entire from the 630, the it will reduce to almost 430 or say 425. So you can completely means say reduce your the payment layers, as well as the thickness of the aggregates, and the weight, the dead load which is coming over the subgrade, that also is getting reduced to a certain extent. Now, geocomposite, we were talking how it can be used in subbase. Now, when it is being used as a chimney drain between a retaining wall and its backfill. Okay, so this is a illustrative diagram which is showing a drainage geocomposite sandwiched between two geotextile. Okay, uh, and this sandwichment is ensuring, as I told, the big thickness reduction. Okay, where a 600 mm or say sometimes more than that and sometimes it is less than that, but average 600 mm aggregate layer, that can be replaced by few microns or few type of drainage geocomposite, that is enormously saving your space consumption. And yesterday is especially this is significant where space is not there, like in a hill road. if we want a little more space for the drainage, aggregate drain, that means that you have to cut the hill or you have to extend to valley, which is having a very high cost. Okay, so we may think like that, oh, fine, for a drainage, a little more space is required. What's the big deal? But look at IRCSP 42 or other drainage codes and see our hill places like Himalayas or Kongan region or Aravalli ranges or whatever it is. So please calculate the width of the drainage, a longitudinal drains or a cross drains, whatever it is, the requirement. You will see that the depth and width is very much higher than whatever we think normally, because the type of the catchment area which is collecting the water, don't consider 100-year return or anything. Okay, that's normally for dams and all. Consider only 25-year return for a normal district road or a state road. Consider that even for the 25 years return period, the type of the discharge intensity what we have to consider, if we design a drain, the depth and width will be much more than what it can be taken. So it's a big jump. It's a big jump of the cost effectiveness as well as the reduction of the natural destruction. Whenever you are cutting the hillside, we are going against the nature. Okay, hill cutting is the easiest way people can go, especially in Himalayas and all, compared to extending to valley side, because the valley side will be a deep gorge, so we will tend to cut the hillside. Okay, but the hillside cutting will cause more and more disasters, more and more disturbance to the natural equilibrium. So in that case, going for a drainage composite is really a big blessing. Definitely this, I cannot tell that any of these products are magic or anything. It is having its own problems and imperfections like any other material, but compared to this big virtue of it can save a lot of space, I will definitely means advocate all of you to means consider the usage of drainage composite. Another aspect is the ease of dealing with. The handling will be very easy. Most of the time, I have seen that the contractors are very reluctant. They will implement even the complicated drawings, whatever we tell. But when it is coming to the drainage, especially in hills as well as in coastal areas, they're so reluctant. They're so reluctant to say incorporate that, because first of all they consider that it's not, what is it, great in it, water has to flow, I will make it, this is it. But the implementation, now that is what we were talking from the morning onwards. So much importance is there, and we really have to encourage them to use it. So the placement is, there is a big advantage. The productivity, that the length of drain what we can place within a day or within a week will be much higher than going for going for aggregate drain. Now, what is the limitations? Okay, we have seen that it can save a lot of space, it can reduce the material consumption, it is having very high durability, because most of this geosynthetics, once it is protected against sunlight, it will stay forever. And most of the good manufacturers will be having the certifications for 120 years survivability and durability. So there won't be any problem. It is a factory produced material. So once time quality is checked, then it will go in the same way. I told that the it is easy to place, so simple to handle, and productivity is quite fast compared to the aggregate drain. All these are good, but definitely there are some limitations also. What are these limitations? One is, which I mentioned earlier also, when the pressure comes, there will be a deformation for the the size of the geocomposite. Okay, So normally up to a very good pressure, it will work perfectly. There will not be any volume reduction. There will not be any deformation. It will work perfectly. Okay? And it is the responsibility of the geosynthetic manufacturer or supplier to produce the graph or the table which is showing that up to what pressure that particular drainage geocomposite can take without any deformation. Okay. So normally for any geosynthetic product, as client representative, you can ask for the technical data sheet. But when you are asking for technical data sheet for a geocomposite, please ask for the pressure volume change graphs. Okay. And that will make you understand that up to what pressure I can use this drainage geocomposite without any distortion or deformation. And it's so important because then only the whatever he claims in the technical data sheet will be valid. If it is getting deformed, it will be partially only valid. So it's so important and it need to be asked. So if we are say summarizing the points what I told, the problems with the conventional drainage media is unavailability of cheap granular filter media, poor gradation of gravel media, choking of media. Yeah, gravel drains can get choked. Whereas the advantages of geosynthetic drains are, it is definitely there is a big cost effectiveness is there. You can achieve directly 30 to 40 percentage of cost advantage. Then customized performance to suit application. It is a tailor-made material. Like you can take a fabric and and say make your dress, different types of shirts or pants or coat or anything. It can and say we can customize it very easily, and it's easy to handle. It is simple to construct. It is simple to transport, and it's the productivity what one can achieve with this type of systems are far better than the conventional material. Okay, so I'm not again talking about one by one what is the advantage, disadvantage, and all. We already crossed it, and these presentations will come to you. You can see this table, and you will see that it is already we have covered all this. Now about the most important part, that is about what are the standards and codes which are published by IRC or Ministry and Bureau of Indian Standards, which is talking about the drainage. The first and foremost, it's a classic code, IRCSP 59 2019. It is for all geosynthetic applications in road payments. Okay, so here we are talking about all different types of products and its applications are briefed in this code. And for drainage geocomposite, if you are seeing the introductory chapter, it is getting described in where it stands in the family of geosynthetic structure, where it stands, that is there. Then the second chapter, it is there also. It's and I say talking about the selection and all. Then the third chapter, fourth chapter, so it's talking about the different tests to be done. And in the fourth chapter, when test is being done, what values you have to get. And then there is the analysis and design part. It is talking about how the design is to be done using the drainage geocomposite. Then a construction aspects, that also is mentioned in IRCSP 59. So again, it is a thin code. It's not very heavy type of book. Somebody who wants to know more about the drainage geocomposite definitely can go through it. Then coming to the MORTH Orange Book, session 700, please go through that for the drainage geocomposite, the different types of applications, the specifications requirement, all these are briefed in MORTH 700. And there is a small correction which is required in the technical parameter requirement, whatever it is given in MORTH. But I think the revision, the expert committee now working, they are really considering that to revise that. A small correction is required for the drainage geocomposite. I will tell you what is it. It's specifically for the, as I told that drainage geocomposite is a combination of a drainage net sandwiched between two geotextiles. So the strength of the individual member as well as the composite is being given. Okay. So drainage net, geonets property, geotextile property, and the composite property all are there. But by mistake, I think the composite property is shown as the drainage net property in the MORTH current uh, uh, release. But it is within a year or something, the new release will come and this problem will be solved. And definitely we can now depend on IRC-SP 59, as well as there is one more code, IRC 34. I mentioned a number of times in our class in the part 1 session. So IRC 34 also is giving perfect specification of drainage geocomposite. Then IRC 752015, there also the mentioning of the drainage and drainage geocomposite, that is there. And another code which is talking about the drainage and the different types of drains and the drainage geocomposite, that is IRC 1132013. Okay. Okay. Then IRC 34, we have seen a lot of things. We mentioned about waterlogged areas, how to give, then hill roads, how to give the toe wall. Whether we talked about whether it can be a gabion wall or it can be a dry masonry, but it should be permeable. So all these are from IRC 34 2011. Okay. Then IRC 562011, it is for, in fact, the publication is for erosion control, but it's really speaking about how the drainage and erosion control has to be given together. But the most important code, the entire today's session, if a single book you want to refer, you don't want to go for so many books, you want to refer one single code or one single book, that is IRC SP 422014. This is also getting revised, but it's a very authentic reference book which is published in 2014. Okay, it is covering most of the aspects what we have discussed today. Okay. Now one more thing, I talked about IRC SP 59 is talking about the construction methodology. So if you're asking which chapter, it is chapter 5. And the chapter 5, 5.2.2, the clause numbers, if you want, you can note it down, 5.2.2, 5.2.3. All these are covering the methodology. Okay. Now let me talk about some other provisions which is given in the IRC SP 42, like provision of sand blanket. Okay. So what is the function of sand blanket? Normally, the sand blankets are for using as a cutoff. If capillary flow is there, then a capillary cutoff is a must. So in that place, we may have to design a sand blanket. Okay. So then what is the purpose of that sand blanket? In fact, it will act as a horizontal drain, and at the same time, it will disrupt the capillary flow. So if we have to construct a rod in a place where capillary rise is there, then we can place a sand blanket. You can place a geosynthetic drain also, but let us look at the sand blanket. How we will decide that the thickness of the sand blanket. Okay. So the SP 42 is giving a definition. T is equal to, that is the thickness of the sand blanket is equal to 8 by D raised to 0.92. So this thickness of sand layer in centimeter, it will be, we are getting it as per centimeter. D will be equal to, what is D? 2d1 d2 divided by d1 plus d2. Then you may ask that what is d1 and d2? Okay, so d1 is the aperture size of sieve through which the if we are doing a sieve analysis from the gradation of the sand, and the d1 is the aperture size of sieve through which the fraction passes, and d2 is the aperture size of sieve on which the fraction is retained. Okay, so we are taking these d1 and d2. From that, we will get the d, which is actually the mean particle diameter in millimeter. Okay, so if it is a uniformly graded sand, this d1 and d2 will be same. It will be equal to d. But if it is a well graded, or means as a non uniformity is there, there d1 and d2 will be little different. So it is to ensure that we need to use the mean size. Okay, so let us take an average size is the d. So 8 by d raised to 0.92, that should be the thickness of the blanket. So you can try, it is a very small equation, and using that we have to define the sand blanket or the capillary cutoff layer, okay, which will act as a horizontal drainage layer, which will be disrupting the vertical capillary rise. Okay, uh, now I told that we can go for a drainage composite with the one side geomembrane and the other side geotextile, and in between a drainage net that can be used as a capillary cutoff. But just like I told that a geotextile also can be used as a drainage layer. The same way, a geomembrane also can be used as a capillary cutoff. We don't have to always go for a complete drainage composite. Just a HDPE sheet that can also act as a capillary cutoff. Okay, but what will be the problem? It will only act as a impermeable layer. It will not drain. Okay, so we may have to combine either sand or a geotextile layer if the entire system to work. So some of the codes, they are just talking about the HDPE sheet only, but the IRC 59 or IRC 34, if you're seeing that, none of these codes which at present prescribed for the highway engineers, that's not recommending the HDPE sheet alone. Okay. Now, provision of drainage composite for capillary cutoffs, the properties, geotextile properties, we can see that upper and opening size should be less than 0.15 mm, tensile strength as per EN ISO 10319, it is defined as greater than 8 kilonewton per meter. Permittivity, which is a hydraulic function, tensile strength is a strength function, hydraulic function permittivity as per EN ISO 11058 is greater than or equal to 100 liters per meter squared per second. Now, mass per unit area, that is properties of the drainage net. In fact, mass per unit area doesn't have that much significance. Okay, it's like when say what is the weight of a person. Okay, that's only whether it is indicating the quality. No, not that much. Okay, so if he is a good engineer, whether the weight will be means indication of his performance. No, it just means showing the health factor only. All right. So the same way, mass per unit area is the health of the geosynthetic will come in the picture, but not more than that. Performance is related to the other factors, but still weight is one of the factor. So mass per unit area, that should be greater than or equal to 410 GSM. Waterproof, if the impermeable geomembrane, if one side is with a geomembrane, what are the properties of that geomembrane? Its wide width tensile strength should be greater than or equal to 13.5 kilonewton per meter. CBR puncture resistance. It's important for a geomembrane. Okay, geomembranes are impermeable. They can be smooth or textured, but they can get punctured very easily. Okay, so CBR puncture resistance is important. It should be greater than 2.2 kilonewton, and in plane permeability at hydraulic gradient I is equal to 1. It is defined for two pressures, 100 kPa and 200 kPa. At 100 kPa, it should be more than 0.6 liters per meter per second. And for 200 kPa, it will be greater than 0.55 liters per meter per second. I want all of you to note that the pressure is increasing, the capacity is getting reduced, taking the hydraulic gradient as constant. Okay, and thickness of composite material should be greater than 5 mm. Now, another terminology. So we have seen the capillary cutoff and sand blanket and drainage geocomposite. Another term is fin drain. Any idea what is a fin drain? Okay, I will tell you simple way. Okay, simple way we are going to the different clauses what is described in IRC codes. When we are using a drainage geocomposite as roadside longitudinal drain, we can call it as a fin drain. Okay, before reaching to the fin drain, another terminology which we need to address, that is French drain. Okay, the French drains, different types of French drains are shown in 4.3.2.7 of IRC 34. Okay, the IRC 34 clause numbers are funny. It means say quite lengthy clause numbers. So 4.3.2.7, the French drain is defined. What is a French drain? Instead of a drainage geocomposite, you are using the roadside drains, longitudinal roadside drains, using the aggregates which is enclosed in a geotextile, that can be called as a French drain. A French drain or weeping tile is a trench filled with gravel or rock or containing a perforated pipe that redirects surface water and groundwater away from an area. Okay, so it's something which will be just a combination of a geotextile and the the gravel or aggregate drain. So there are two images. What is the difference between the first image and second image? In the first image, there is no porous pipe, whereas in the second image, there is a porous pipe. Okay. And what are the common factors in the first image and second image? The image A, there are the aggregates are there, which is confined in a geotextile wrap or filter fabric, and in the second also the same is there. Okay, so this is figure 4.5.2.6 of IRC 34 where French drains are defined. Sorry. So we talked about the aggregate drains which are in regular shape, but the aggregate drains can be of different shapes as per the suitability of the space available. And if you are going about the aggregate type, whether it has to be metal or whether it has to be crushed rock or whether it is to be river rock, it means honestly depends on the type of the project. If it is a very important project, we have to go as per the gradation but it is defined in MORTH 700 or IRC SP 59 or IRC, most importantly IRC SP 42. Okay, so that is there. But if it is a use in a rural area where unimportant roads and all, we can go for whatever the locally available gravel or crushed stone which is available. Now, about the specification of the pipes which are being used in these aggregate drains. Again, it's if it is the side of a very important type of highway and all, the pipes need to be designed. Pipes and the culverts and all very precisely need to be designed. But if we are going in a rural area, there we have to. It means NSC basically the pipes diameter, because in rural areas most of the surface water will be taken care by the vegetation around it. Okay, so the use of the subsurface drainage and all that, only the basic capacity is required. So there we can use the different, the only specification requirement will be, okay, the type of the material as well as it should be a perforated pipe. Now, fin drains. Okay, so the French drain, we have gone through that. What is a French drain and how simple it can be? It can be through with the pipes or without pipes. It will be normally a roadside drain where the aggregates will be there and a geosynthetic enclose or encasement will be there, which will be a geotextile. So it is like wrapping with a fabric. Okay, whereas fin drain is where a longitudinal drain where you are placing a geocomposite as such. Okay, so I'm not going to the very details because we have talked about it continuously. Figure 4.5.2.7, the fin drains, which is given in IRC 34, the same image I have taken here, just copy and pasted. Okay, so two types of fin drains, a drainage geocomposite. The first one is again left one without the pipes, and the right one is with a pipe. Okay, so even if it is showing an excavation and with some good dimensions, in fact it is, the width is quite small and the depth is significant, and the filter fabric can be introduced there, which will be acting as a subsurface drain effectively and which will carry to a longer length. Okay, and once it is being closed, the space consumption is absolutely nothing. Okay, so the entire subsurface flows will be taken care by this. And only thing, as we talked, the drainage composite, whatever we are using for this type of fin drains, we have to take care of its capacity and performance under different pressures, whether it is 100 or 200, whether it can retain its shape and it can perform, that need to be checked. The manufacturer or the supplier should give the technical data sheet with the relevant tables and curves. So we were talking about IRC 34 fin drain and French drain. So now let us look at the two references, that is the clause number 5.2.1 of IRC SP 42. So here for the drainage layer, the specification is defined in a table. So the geotextile properties, apparent opening size and permittivity, it is the same what we have seen for the French drain. Then property of the composite material, that also is defined. You can see again the same, the different pressures, 100 kPa, 0.55 liters per meter per second, whereas 200 kPa, 0.45 liters per meter per second. Okay, so you can see that this same table with the little small difference here and there, you can see in a number of codes. IRC SP 42, IRC SP 59, MORTH, even if there is a small mistake is there, that also we can see that all are talking about the strength, especially CBR puncture strength, that will be there. Hydraulic property, what are hydraulic properties? Hydraulic properties are permittivity. What is permittivity? Permittivity is permeability divided by thickness. And then size, apparent opening size. So these are the most important components. As I mentioned earlier, mass per unit area is, it is just a symbolic how healthy it is, like in the case of human beings. Mass per unit area is not promising any type of performance guarantee. Okay. So one need to ask, when we are selecting a drainage composite, the most important parameters are permittivity and apparent opening size, CBR puncture strength, and maybe we can ask for the tensile strength also. Okay. And more importantly, with the pressure changes or the force changes, whether any deformability is there and whether it will affect the permeability, that need to be checked. For that, the table or the curves can be demanded from the manufacturer or supplier when he is giving the technical data sheet. It may not be in normally in the websites and all where manufacturers claim put their technical data sheets. That's why you have to ask specifically. So different types of drainage composites are there. It's not always it will be the same type of geonet. The different manufacturers are making their own changes to have to define their brand identity. But the what a designer or a client need to address is the filtering component, then adequate permeability, then the retention capacity, the draining performance. So these need to be checked. And shape should be, whether it should be like a cuspated, whether it should be net and all, that doesn't have that much importance. So this is one type of drainage composite to show you how the geonet can be of different shapes, and the geotextile, it is folded back to show you the geonet. Okay. So whatever we are seeing, where a circle is drawn, that is another type of geonet. Okay. Another type of geonet which is sandwiched between two geotextile. And what is the left side image? The left side image is a retaining wall and where a drainage composite is shown and a pipe is shown at the bottom. And we talked about this type of vertical drainage. The mechanism will be, this illustrative figure is showing the mechanism. So when we are inserting a vertical drain using a drainage geocomposite from all adjacent place where backfill is there, the water particle will move towards this, the drain, vertical drain. Okay. So the drainage net will be, means and see, creating a space which will attract the water particle towards it. Okay. And the filter, the geotextile on either side, that will allow the water to go to the annular space and it holds the soil particles there. The soil particle which is getting silted around the drainage composite will be called as the drainage cake, and this cake, soil cake, will be increasing the efficiency of the filter. Okay, it is not going to clog if the drainage composite is selected and designed in a proper way, but it will increase the effectiveness of the filtration. Usually that question used to come whether clogging will happen. Okay. So I talked about the importance of permittivity or the permeability, the apparent opening size, the CBR puncture resistance, the tensile resistance and all. But one main aspect I forgot to mention, it is about the clogging resistance. If the geotextile is getting clogged, the entire purpose of releasing the pore water pressure and all, that will become zero. Okay. We will be completely failing in the attempt of providing perfect drainage. So the geotextile should not be clogged, and the design for clogging stability, anti-clogging stability, for that also we require the same parameters: the apparent opening size, permittivity, and gradation of the soil. Okay. So permittivity criteria and clogging resistance criteria both will be governed by the same type of calculations. The calculations are the apparent opening size, the permeability, and the soil type. D50, the average gradation of the soil particles. So, as these two images, the right side is a common aggregate drain and the left side is a drainage geocomposite. Definitely with the drainage geocomposite, we will be achieving more increased efficiency and saving of materials. Okay. Let me little skip now because we have talked enough about drainage composite and its advantages and all. Okay, and for the design, I will recommend either go for IRC SP59, the design criteria, or you can go for the IRC SP42 for the drainage geocomposite. Definitely IRC SP59. For the general drain, it is better to go for IRC SP42. So this is the placement of drainage geocomposite. You can see that it is just rolling out, okay, vertically or horizontal. Where you require a horizontal drain, the left image is rolling out horizontally, okay, and the middle as well as the right side image is how vertically you can place a drainage geocomposite, okay. So we don't have to that much worry about the contractor whether he will do in a perfect job or not, because it is so easy. You have to just means roll it out and remove all type of undulations and all. That's it. So the contractor cannot means and see the reduce the quality here. Once the quality is checked when somebody is procuring from the factory of a manufacturer, definitely a factory visit and initial testing is required. But once it is coming in the site, what need to be checked is whether everywhere he is putting as per the drawings. But we don't have to means and say really in between random checking the quality of material and all. So overlapping is important. Again, the advantage of going for drainage geocomposite and all, there is no requirement of big lapping joints or welding or anything. You can just overlap, and that also not a great length or anything. If the soil is coming over it, or pavement layers are coming over it, simple 100 mm will be okay. Okay. So in some cases, some special cases, we may have to go for 300 mm. If you can tailor it, you can still reduce it. So from IRC SP59 chapter number 5, you will get the construction methodology in a good way. Okay, now there are different types of softwares are available for different companies. So like this is a snapshot, you don't have to see specifically because it is a uh, uh, different brands, different companies are having their own software and all. And in fact, we can design the drainage composite by manual calculations. Okay, the simple conventional drain we can do with the manual calculation. The same way, drainage composite also you can do with the manual calculation, where the software will be useful, especially when we are going for landslide correction and all, where we may have to really see that whether the subsurface flows, how the seeping will happen, because there will be impermeable layer, permeable layer, and different types of permeability characteristics will be there. So we need to understand that through which layer the seeping will happen. Okay, we are inserting horizontal pipes randomly. We may be trying to insert it in a impermeable rock, which will be means troubling the contractor. But if we are doing a permeability analysis, we will understand that where the pervious layer is there, where the impervious layer is there, where if you are inserting an inclined pipe, whether it will be useful, where I have to insert a drainage gallery. So all these can be understood. So for that, the geological understanding is there, and we can means use certain softwares to decide that how the seepage lines will get extended, which will really helping the designer to go for a optimized drainage arrangements. Okay, So we have seen the hills, the different type of situations and all. And I think that in this course curriculum, you will be again taught by different people, different faculties, for different types of drains in hill infrastructure and all. So in the hill infrastructure, the surface drains will be there, like tor drains or intercepting trench drains or catch water drains. Then there are Gabion tube drain or cascade drains. All these are a part of the surface water drains. And usually it will be like a drainage arrangement. A scheme has to be followed, okay, which really will be addressing the drainage of the entire area. Or it can be something which we discussed as chimney drain, okay. So this is the what we are seeing in the images in this slide. So the first upper right side image, where the drain pipes, we are introducing some drain pipes in the hill slope, okay. And that the hill slope, as I mentioned, that the seepage lines and the entire geology of the area should be known to decide that where we are going to insert the pipes, drainage pipes, okay. So that is a situation where judgment, the experience, and everything, and availability of material, all these will be playing together. Now when it is coming to a man-made retaining wall, between the retaining wall and the original backfill strata, we may be introducing a chimney drain, okay. So the illustration, the drawing which is shown in the right side corner, okay. So it is a reinforced soil slope or a reinforced soil wall, where you can see the reinforcements are going within the soil, and a front face, the lower block will be having a gabion fascia, which is completely free draining. Gabions are just rectangular baskets filled with stones, and the upper portion is again a reinforced soil structure with a green fascia, okay. And between the backfill as well as with the structural fill, there will be a chimney drain, okay. So this chimney drain can be aggregate drain, or it can be a drainage composite, okay. Now whether the front fascia is free draining and the chimney drain, is it enough? No. From the chimney drain, there should be a path which will be taking the water out. And in this case, I don't know whether it is visible to you, an inclined pipe is connecting the chimney drain to the outside. Okay. I'm little skipping. Yeah. So now I told that it can be the design of the drain, whether it is a conventional drain or whether it is a drainage geocomposite. When we are using it as a chimney drain, it can be designed. So what are the parameters? We need to see the gradation of the soil, the apparent opening size of the geotextile, if it is a drainage geocomposite, or the apparent opening size, the permittivity of the drainage geocomposite, permeability of the aggregates, if it is an aggregate drain, okay. So next is, if we are using it has a chimney drain between a wall, between a retaining wall and the backfill, we have to know the dimensions of the wall, the height of the wall, the length of the wall, the load which is coming over it, and why we need to know the load and traffic load and everything. We need to know it just because of you have to know the pressure, okay. As per the pressure, we have to see that the any deformability is there. If deformability is there, we have to apply a factor, a safety factor, material reduction factor to it, Okay, somebody who is having the experience of working with the reinforced soil structures, they will be understanding what is the reduction factors. The reduction factors are the various reduction which can happen in the performance because of the different micro level and macro level factors. Okay, so as I mentioned that the seepage lines need to be decided, and for that different types of softwares are nowadays available. And if we can select one of the software, and accordingly if we can decide that what is the in plane flow direction, that will help the designer to really understand precisely how we have to give the drain at what inclination and with the what capacity and in what direction. Okay, so the determination of the seepage line is important. And as I mentioned that we have to decide the pressure which is coming on the aggregate drain or the drainage geocomposite. Okay. So there are the calculation steps are there. The IRC 42 will give the calculation step for the conventional drain, and IRC SP 59 will give for the drainage geocomposite. Both these documents are getting amended now. So within 2 to 3 years, you will get a more better methodology of adopting the drainage geocomposite as well as the aggregate drain. Okay. So now the drainage is very important, especially subsurface drainage is very important when we are going for the ground improvement solutions also. And one of the alternate technology compared to the normal type of the ground improvement like sand drains and all, it is in fact the PVD. PVD is prefabricated vertical drains. So prefabricated vertical drains are again a combination of a central core and the confinement using the geotextile. So we can call it as a special type of drainage geocomposite. And the prefabricated vertical drains, what are the specifications, how it can be designed and on. There are different IRC codes are available. MORTH also, the 700 is speaking about the PVD specifications. And there is two HRB documents, Highway Research Board documents are there. It is HRB, IRC HRB 13 and IRC HRB 14. So these two are the two documents which really written in again 1994 or 95, which really requires a amendment. But whatever it is written in that document, that is really quite good. And even it is talking about the sand drains and PVD and all, it is mentioning. Okay, but if now a modification is coming out, definitely a lot of improvement can be expected, because in our country the use of PVDs and sand drains and all, that has improved a lot. Okay, even the vacuum consolidation type, those type of advanced methods are also now slowly getting penetrated to the Indian industry. Okay. So now let us move to the last 45 minutes. We have to go for the groundwater recharge. Okay. So is groundwater recharging is important. It's so important because we are talking about a lot of the drainage, and why it is important to highway engineers. I think there is no question of it. It's lot of importance is there. But at the same time, why we need to think about the groundwater recharge? Because the draining of water means water is getting diverted. Water is means honestly taking away from the structures, so that it is not affecting the the performance and the quality of the pavement as well as the road performance. So if the water is taken away like that, if that water can be used for some other purpose, then that will be a double advantage, isn't it? Okay, so waste to wealth. that concept, definitely the highway ministry as well as the entire nation at the moment is looking for it. So wherever we feel that something is not useful there or it is causing a problem there, take it and use it somewhere. Okay. So apart from the so many other uses, one major use, the especially subsurface water. We are today talking more about the subsurface, right? So the subsurface water, without much efforts, we can use for groundwater recharge, especially in the road is passing through hilly terrains or rural places and all, where the adjacent land is having a lot of agricultural requirements, or in some cases, we can really use something like a check dam or groundwater dams and all. From there, we can use it for different purposes. Okay, but the idea is use this water in a useful way. So I don't have to tell you that what is groundwater recharging. The name itself, and it knows, it is known by even a fifth standard student. So now, what are the different structures? We all are telling that as we know the importance of the correct usage of water. But what are the structures? Unless somebody is not designing it properly, unless somebody is locating where it is to be placed, unless somebody is clear about that where it will work, and it's the civil engineering projects will not incorporate it. Okay, it should be in the planning itself. Somebody has to visualize that the DPR has to means, and as I mentioned, how it is to be done, specification should be there, then it can be implemented. So now in the IIT curriculum, it is being incorporated because of the ministry's policies to more and more think about the sustainability of the entire region as well as the country, rather than, oh, we are highway engineers, we are land development department, or we are urban development department, or we are irrigation department. So instead of that, there should be an integrated approach also has to be there. So that is why these type of topics are also getting incorporated in the IIT curriculum. So what is a check dam? Check dam or weirs, they are transfer structures either placed in a river body. Okay. So normally if we are going for a bank protection structure, it will be longitudinal structure. But when a check dam will be a transfer structure. Its purpose is to reduce the velocity and increase the deposition. So percolation tank is an artificially created surface water body. Okay, so check dam we told. Now, what is a percolation tank? Percolation tank is, it is different from check dam. So it is a tank which is created for for submerging its reservoir in a highly permeable land, so that surface runoff is made to percolate and recharge the groundwater storage. Okay, so this is the difference. In a check dam, we are completely stopping the water flow, whereas a percolation tank, we are not completely preventing it. Okay, we are retarding it by placing it there. It will be means storing a part of the water, but it is allowing to percolate also. Okay, and the water which is percolating, it means NSA continuously recharging that area. Whereas in a check dam, you have to make a separate arrangement for recharging the ground. So this image is an indicating image for percolation tank. It is shown that a percolation tank is created by placing something like a dam structure, and the when the continuous rain or something is not there, the percolation tank will not be full. But a continuous rain happens, what will happen? This will be means overflowing, and that from that overflow, the water will get collected in some wells, and from that wells, the channelization will happen, which will be recharging the ground around it. So this is an indicative diagram which is showing how a particular area that can be the some wells and pipes. We may have to create some the gully plex as well as contour bunding also, because when we are artificially recharging, again if the water has to stay some time, then we cannot means necessarily think that if it is a complete plain land, then the water may not stay there. We may have to create again some pits, some artificial pits, some gully plex, some contour bunding and all that may have to create as per the different type of terrains. Okay, so in a complete plain area, we may have to go and just create some pits. But if it is a inclined plane, inclined plane, if we are just putting in some pits, that may not be in Senesi, again recharging may not happen. There we may have to create some contour bunding also. Okay, so accordingly different types of undulations we may have to create to make the recharging effective. So recharging is having, remember that, two aspects. One is the water has to reach, second is the water should stay there. Okay, both has to happen. Okay, so the contour bunding, I mentioned that if it is an inclined plane and all, we may have to use this gully plates and contour bunding. Okay, so these are normally the practices which the farmers used to adopt in, especially in hilly terrains, where they have to make the water usable for their crops, and at the same time they have to do it without damaging the stability of the adjacent infrastructure, and at the same time the water which is non-usable or excess should be drained off also. So these concepts, the experienced farmers who is having the local geological as well as geotechnical aspects, the awareness is there in their crude way of awareness. They used to do it in a perfect way, uh, without even understanding the engineering concepts. Now if we can adopt those type of concepts and we can put our elements of engineering with it, an integrated approach will be getting created between the road engineers and the other type of engineering departments. It may be the agricultural department, it may be land development department. So they can work together, we can work together definitely with the inputs from the local farmers or the local land development communities. Okay, so contour bunding is such type of the uh, uh, popular method which involves the placement of lines of stones along the natural rise of a landscape, and these techniques help to capture and hold rainfall before it can become runoff. Okay, because runoff causes the erosion, and if we can, before runoff itself, if we can hold the rainfall, that definitely means NSA will be contributing. They also inhibit wind erosion by keeping the soil intact. So it is not only for the water, the drainage, it will be having the other complementary effects. It can prevent other type of erosions also. So what is the difference between contour bunding and contour trenching? So contour bunding is more about creating the folds or the bends uppers, whereas contour trenching is, it's more in the making the pits or depressions, and the contour trenching is more for to increase the agricultural production, and wherever the land is, as I told, that relatively plain, you go for the contour trenching. Okay, whereas contour bunding is more in places where a lot of sloping surfaces are there, where the contour trenching may not be that much effective. So the recharge pits, when we go for recharge pits, again, as civil engineers, we need to see the stability aspects also. So one can go for a deep and wide recharge pits wherever it permits, but in some cases, the going for a deep and wide recharge pit may be affecting the overall stability of the area. In that case, we can use a recharge pit in combination with the recharge shafts, because once you are collecting the water from the rain, what we have to do, we really have to recharge the ground. For that, we don't have to make the entire the recharge pit to go down. We can make two or three shafts, and those shafts will recharge the area, and it will be means keeping the stability of the area in a appreciable way. Now dams, okay, dams, definitely we know the dams, especially the irrigation dams. Then we already talked about the check dams and all. Okay, so the now especially for the groundwater dams. Okay, normal dams, whatever the hydropower dams and all, we more think more about the surface water. Okay, surface water, and how we are controlling it or channelizing it and all. Now about the subsurface water or the groundwater dam is a dam or any structure to intercept the groundwater flow through an aquifer, or whether it is a natural aquifer or an artificial aquifer, and provide storage of water underground. Okay, so suppose there is a aquifer is there, and if we want to really means and say use the water from that aquifer, we need to ensure that it will be a constant supply. So we can really keep the dams uh, near the vicinity of this aquifer, and then see that during the monsoon time and all, whatever the water getting infiltrated from the surface and becoming a subsurface water, and the aquifer itself will be having means and say a lot of expansion at that time, and the increased capacity will be managed by the dam, as well as the subsurface dam what we are creating, and the accessories we are creating, and then it can be used for irrigating the nearby lands, or artificially recharging the places where we are developing some gardens, or uh, uh, the grasslands, or lawns. So these type of dams will be helpful for doing that, especially in areas where there are places where just between the two places on two sides of a hill. One place is means completely green, lot of aquifers are there and all. Whereas the other place just adjacent village in the other side of the the hill, there is not uh, enough water, and a lot of the villagers are suffering due to the scarcity of water. So those type of places, this will be quite useful. So for your information, these type of situation which I explained now, this is not a imaginary story. I know a number of places in states of India, like in Karnataka, Tamil Nadu border, Tamil Nadu Kerala border and all. In number of places this type of situation is there. Just two adjacent villages, one village is means blessed with a lot of greenery, lot of groundwater, surface water, everything, and just adjacent village, it's there is nothing. It means and say totally different. So this type of sharing will definitely means and say not only improve the fertility of the land, and the cooperation, it means definitely the that unity of the entire population and the humanity to means for a common purpose. Yes. So, this when we talk about this type of special arrangements, apart from the normal concepts of artificial recharging, this really requires um, a team of people who are cooperating with the multiple specialists who are having the knowledge in geological details, the geotechnical investigations to be carried out, hydrological details, and the especially the knowledge on the aquifers, the channelization of the water through underground. So all these are a number of aspects are there, and uh, definitely this is possible because these type of structures are not anything new. Okay, these are being constructed in the prehistoric time onwards. These concepts were there and our ancestors were doing that. The with the advancement of the technology as well as the education and all, instead of going means honestly advancing over it, in fact our mentality to cooperate or coordinate and all, that's having means honestly the less quality compared to how our ancestors were doing when the communication facilities were less, when the availability of tools were less, the digitalization was not there. So that time they were doing because of the ability to means understand, the ability to, or the empathetic nature. This was getting done in a, even if in a crude form, this was getting done in a higher quality level, whereas the at present, I'm sad to say this, many of the departmental the government departmental engineers, as well as, forget about if the government departmental engineers are like that, then let us forget about the private or the contracting companies. So the way we are looking at every engineering project is that what I have to do, I will do only that. I don't have to do anything beyond that. And what is in my contract, I will do only that. Okay. So this means NSA way of we are limiting ourselves. Apart from all the noble causes, I want to say that that will be limiting in our learning also, because when we go for this type of the entire holistic development, as well as the concepts of recharging the ground and all, multiple engineering disciplines has to work together, and it's a lot of learning opportunity. So that's my the concluding statement. When we are restricting ourselves on only what essentially which is being put in the contract, I will say that even the contract document preparation, the DPRs and all, that has to incorporate the concepts of the artificial recharging, the concept of the sharing the natural resources, converting the waste to wealth. That has to start from the DPR preparation itself. Definitely, there will be a lot of restrictions once the DPR is formed and the contract is awarded. The contractor, the engineering implementation units of the client organization, the consultant, everyone will be having the limitations. So it is better these type of the holistic approach has to be starting from the planning stage itself. Okay, so my question is, shall we discuss a bit, because it is now 12:38. So I don't want to ask that 12:55 to all of you that, okay, can we discuss something? So I would like to means and say hear something from you. Definitely the online classes, even if IH request, it used to be very one-dimensional. So can we make it a little interactive now?
Good morning, madam.
Yes.
I am Suresh Babu, working as executive engineer in Andhra Pradesh. Madam, I have a small doubt. Previously, around 40 years back, our roads were laid on the canal bunds on the plea that the cost of formation will be zero. Say, suppose the soil coming from the canal is only 2%, for the saving the formation of embankment, they utilized that as a road, for the first time being as a jeep track. Then it was transferred to other departments. Slowly vehicles are going on. Large vehicles up to 70 tons are now going. The problem is when the crust is around 1 meter, different layers of WBM were used and the crust was around 1 kilometer, 1 meter. Still, it is settling because the subgrade is weak. Is it possible in such a case to construct road dams on the drain? If you construct a road dam on the canal of the road, the water will be stagnated and the subsoil will be get more saturated and the road will settle more easily. This is my opinion. Still, some people are taking up the roads and the canal ones. Is it correct or not? My question is over.
Yeah, sir, I was not able to hear the entire thing, but I really understood from the bits and pieces I was able to hear. It is a very relevant and interesting question. It is connected with the canal bund, right? Sir, whether the road can be taken along a canal bund. Is that the question in
Yes,
summary?
the earth excavated from the canal
Ah,
used as a bund, and
yeah,
there are will lay the road crust.
yes,
In such a
right.
case, if you stop water or ponding water on either side of the road, may
Mm-hmm.
worsen the situation. That is my doubt.
Right. Yes, okay. So, sir, see, my experience, sir, I worked with a number of projects where this type of dredged materials were being used for constructing the canal bunds, and the top of the bund is being used as a road also. So, the first of all, the point is like that. As per me, one aspect is the height of that bund has to be quite higher level, okay, because as you correctly said that it means and I say the water percolating and all these will affect, so definitely at a higher level. Second is when you are taking higher level, then definitely your base width as well as the side slopes are to be really designed with a for stable geotechnical analysis has to be there to get a stable embankment. Then the third is that the slopes need to be protected properly. If a retaining wall need to be there because of the geotechnical instabilities that need to be placed, and even if it is geotechnically stable, erosion protection should be given. Erosion protection and even drainage, chute drains and erosion control measures need to be provided. Now one more thing, if you are using the canal bed material, that canal bed material most of the time, especially for South India, Andhra or Karnataka or Kerala, all these places, the it will not be the pure silt or pure sand. It will be C5 soil. Okay, caution also will be there, and so there can be settlements and uneven settlement. So definitely a analysis need to be done by taking the soil whether any chance of consolidation consolidation settlement. And if consolidation settlement is there, we need to use some methods for improving it before you are creating the embankment. So I completely agree with you, but I cannot say that it cannot be done. It can be done, provided that we have to really make it stable by different methods. And the failure mechanisms which need to be checked, as a geotechnical engineer, I can say that even for just a geotechnical stability, at least 6 failure mechanisms we have to consider: bearing capacity, the settlement, then the lateral squeezing or plastic squeezing, then the forward sliding, okay, and the overall the erosion, okay, and a global stability. So just in geotechnical means, I can tell this many are there. Then imagine that, okay, fine. When the traffic load is going, there are in presence of water, whatever we have talked about. So all those type of deterioration is possible. So we have to strengthen the payment layers. We may have to strengthen the subgrade. If any chance of capillary rise or something, a capillary cutoff need to be provided. So at the end, we have to think that are we doing the right thing, or whether we have to go for this, or whether any other alternative is there. But if no other way is there, yes, it is possible. Only thing that it need to be analyzed and adequate measures need to be taken. Otherwise, it can be means that it can get settled, it can be breached out, lateral squeezing can happen. Okay, so a number of problems can happen. Yeah, sir, I hope that I addressed your the question.
Sir, madam, the
Yes.
problem is the people who have done the mistake long back,
Ah.
they used the subgrade soil with the 2%.
Ah. Okay.
They
Okay.
ready for 6 meters and later laid some gravel 150 planar subbase. We do not have mechanics madam or something like that. We were having only this waterborne macadam.
Okay. 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 Yeah. Yeah.
That road sinks every year. We used to lay 2 layers of WBM.
Yeah. Yeah. Yeah.
So now
I
the
understand.
has come to a depth of 1 meter, but the road still sinking.
Yeah. Yeah.
Uh, Instead
I
of
can.
making the canal
Mm,
here, one can take a separate land and farm with good CBR material as upgrade
Yes.
and form the crust over the subgrade.
Yes, you're
More
absolutely right, sir. It is means, and see, just see, nobody wants to go down and do the thing. That's the problem. But then the problem will never stop. It goes on. So you are absolutely right, sir.
thank you.
Yeah. Any other question or remarks or anything we need to discuss?
Yes, ma'am.
Yeah,
Good
please.
afternoon, ma'am. This is AK
Hi.
Singh, General Manager of NHIDCL, speaking from Nagaland.
Hi, sir. Yes, sir. You are
Yes, yes.
welcome. Yeah.
Yeah, we are trying to embed the perforated pipes below the subgrade so that the at least drainage problem can be addressed.
Right.
So I hope I am in the right direction. Or should we substitute the bituminous pavement by concrete pavement? I mean, this
No,
is
no,
yes, ma'am.
no, sir. No, I feel that, sir, you are in the right track.
Yeah,
You don't have to jump from bituminous to concrete, because in the concrete will deteriorate faster in presence of continuous moisture. Okay,
okay.
concrete is having its own advantage. Definitely, we all know that, but it is having its own disadvantage also. So
I,
I think you are perfect in your approach by increasing the drainage by putting the perforated pipes and on, rather than
yeah.
jumping to concrete.
Okay, ma'am.
Okay.
So wonderful. Now the second question is, as you rightly told that use of geosynthetics will
Yeah.
substantially reduce the consumption of aggregate, and the thickness will reduce from 630 mm to 430 mm.
Yeah.
Yeah. So some stretches in Himalayan stretches also,
Mhm.
sometimes we do not get enough quantity of aggregates, etc. Because
Hmm.
everywhere there are so many construction agencies
Yeah.
nowadays,
Yeah.
private builders also. So can we
Yeah.
opt for geosynthetics, reducing the thickness of the WMM from 250 mm to, let us say, 175 mm? Uh,
Yeah.
GSP is 200 mm, okay, that is drainage layer, so I do not want to compromise on that. But
Right.
further, the WMM happens to be the base layer.
Yes.
So if we design it like that, so will it be advisable to opt for that sometimes?
Yeah. You can go for that. Only see, the material which need to be used is either a geogrid, extruded type geogrid is most effective. You
Yeah,
can use other types of geogrids also, but extruded geogrid with less strength you will achieve more. So you can go for that, or in your drainage geocomposite,
yeah,
even there are material which is, I told you that one side geotextile and a drainage net. So in that also there can be some fibers with higher tensile strength. So those type of combo is there, which is not so popular in India now, but
yeah,
we can imagine that within a few years those type of products also will come. So with a single material, then we can achieve number of things like drainage, reinforcement, everything
okay,
in one single material. But at present, we do have a number of manufacturers in India. We used to get in a good competitive rates
yeah,
geogrid separately and drainage composite. So if you want to replace sub base or reduce the thickness, you go for drainage composite. If you want to reduce the WMM thickness, you insert a geogrid, extruded geogrid, and you can means NSA select the extruded geogrid. Suppose a 20 kilonewton per meter, which
yeah,
may be enough for normal district roads or normal up to state roads. Okay, national highway you may have to go for 40 kilonewton per meter
yeah.
because your traffic load is higher. So that IRC SP59 will guide you how you have to select. There are some workout examples and all, but definitely with the use of geogrid you can reduce the WM thickness.
So what will be the appropriate placement of the geogrid? Will it be above the GSB layer, ma'am?
We can see when we are doing it for the actual field, it will be better to give in the junction. Okay, like the GSB, say the base and sub base junction, or the base and bituminous layer, the junction. Okay, when theoretical design, people used to show that at the middle. Okay, but the middle, if you're doing, you have to place the base layer itself two times. The contractor will have to do two, which they may skip.
Yeah.
Okay.
So
So in
at the
practically,
junction of G
yeah, junction you can.
Okay, got the point, ma'am.
Right.
So
Right.
as you have rightly told that there will be much scarcity by 2030, but
Yes.
we are already feeling the heat of scarcity of materials, especially for sand, because Nagaland, though we do not have sand, we have to bring it from far away from Assam. And
Yes.
coarse sands are not so available because they are much in demand. So there are a lot of tussle
Yeah. Yeah.
between the authority and the contractors. Um,
Yes. Yes. Yes.
Ma'am, one
That
last
is.
but not the least,
Yeah.
ma'am,
Yes, sir.
question.
Yes,
Yeah,
sir.
ma'am, we are using the geocomposite
Yes, sir.
backfill behind the retaining wall and breast wall, and
Yes.
filter media also we are providing. So
Yes.
filter media also 600 thickness, 600 it
Yeah.
consumes lot of material. So
Yeah.
if we do not provide the filter media, and if we provide let us say some clay material also, or coarse granular material behind the geocomposite wall, so is there any longer requirement of the filter media behind the backfill?
Yeah,
If we,
sir, I will say that, see, we can go for this drainage composite,
yeah.
and with a very thin layer, say 100 or something, the coarse grained material, you can go up to some 10-meter retaining wall and all easily. Okay. But
Mhm.
uh, yeah, you don't have to again provide means, say 600 or anything, definitely. Even drainage geocomposite alone also can be used,
Yeah.
provided that the good type of yeah, sir,
Composite.
yeah, sir, let me complete. So
Yeah.
if you are means, say, going as per the quality standards in a good way, you can use the drainage composite alone, or even a geotextile. But
Okay.
unfortunately in our country,
Yeah.
nobody means, say, go in a perfect way. Okay. So
Mhm.
now the MORTH is the when it is getting improved, or this chapter which is of geosynthetics,
Yeah.
and there is a chapter 3200 which is for reinforced soil. The expert committee is really thinking of providing geocomposite and some gravel layer. Okay, but that is
Okay.
not 600, that is means up to 300 only. And
I
this can
see.
be used for very high, like 20-meter high wall, or 15-meter high wall. There are also
Mhm.
300 plus drainage composite. Okay. So for
Okay.
low walls you can use drainage composite alone. Okay. High walls you can use means, I say, combination, but no need to put again 600. Then what is the economic advantage we are getting? We are not getting economic advantage if you are completely going the two. It is not required.
We are
So
constructing only 3-4 meter high retaining breast wall, retaining
you
structure.
no say there. I see. I need to see that exact situation, sir. But
Yeah.
there is no requirement of complete filter and then geotextile, and
Yeah.
it's
Yeah.
not required,
It will
because
be.
geotextile function or drainage composite function, their filtration is already covered. The
Yeah.
drainage composite, one side it is a geosynthetic that is acting as a filter. Acting